All right, everybody. Hopefully you are all doing well. I know some of you have been absent the last few days, or perhaps you have had a track meet or other event and have missed some of what we've gone over, especially in the second half of our lesson about water quality. So we're going to kind of revisit that here in this video. So starting off with reviewing a little bit of what water quality is, and this is already in your previous notes, but we'll go over it again here. And we know now that water quality is the chemical, the biological, and the physical status of a body of water. But there are a lot of things that can affect water quality. We spent the first half of the lesson talking about the different tests and things for water quality, but now we're going to take a look at what kinds of things actually change the water quality somewhere, and it can affect the water quality. Some of those things are natural, like seasonal temperature changes. In the winter, it's really cold, so the water's really cold and it freezes. In the summer, the air is warm, and so the water gets warmer. It's natural. It happens. And it does affect water quality. Also, the weathering of rock and soil. So as water runs over rock and runs over soil, it carries little bits of that rock and soil with it, carries it through the water, and that can affect the water quality because now there are different substances that are in the water than were there before. Runoff from rain also can affect water quality. As the runoff, it rains and hits the ground and then runs off the ground into local streams and rivers and other bodies of water, it carries substances with it. The rainwater carries substances with it into the water, and that can affect the quality of the water. Then there are things that are not natural that happen that can also affect water quality. For instance, things that humans do, that people do. There's pollution from factories, from cars, from motorcycles, ATVs, lawnmowers, whatever it might be. But pollution from those things can run off into the water. And then deforestation, where you have a large area of trees that are cut down. That can also lead to soil erosion, which means the roots are no longer holding the soil in place. Then when it rains, it's easier for that soil to then run off into local water sources. Pollution. We've talked about pollution, and we know that it can be put into two categories. Some pollution is known as point source pollution. That kind of pollution can be traced back to just one single location. It might be a smokestack, it might be a single drain pipe, or something like that. But there's also another source of pollution, and point source we've managed to get a little more control over in recent years by making laws about how much pollution can come out of a smokestack or out of a drain pipe. And we've been able to track down some of the smokestacks or drain pipes or other things that have been causing more pollution than others and try to remedy that. But non-point source pollution is a little harder. There are things we can do to help control how much pollution is created in non-point source places, but it is harder to keep track of because it can't be traced to just one location. It's much more widespread. It might be pollution that comes from a whole lawn, or maybe a bunch of lawns in a neighborhood, or maybe it's pollution that comes from a parking lot because as cars drive around in the parking lot, they leak oil or gas, or the little bits of rubber from the tires wear off on the ground, and then when it rains, that stuff gets picked up by the rainwater and carried into the local water sources, or the same thing with roads. So we've talked about testing water, but in order to do tests like dissolved oxygen or pH or turbidity with a Secchi disc or testing the temperature of the water or things of that sort, you have to actually be there. You have to be hands-on and you have to be at the location. And that's not always a practical way for scientists to be able to test things. It also can be costly because it can cost a lot of money for some of those tests. Some are cheaper than others. So scientists have found other ways that they can observe changes in water quality other than always using tests to test the water quality. One of those techniques that they use is observing bioindicators. So this is kind of where earth science and life science collide. You have earth scientists and life scientists working together to observe bioindicators. A bioindicator is an organism that's sensitive to environmental conditions. In other words, they are just not tolerant of pollution. They can't handle the pollution, and when there's even just a little bit of pollution in the area, they begin to get sick or mutate or even begin to die off. So if a scientist observes an organism that they know is very sensitive to pollution, it's not tolerant of pollution, and they notice that they are getting sick or mutating or they're just plain missing because they have died off, then they know that there is probably some poor water quality in that area and they need to do some further testing to find out what's going on. At this point, it becomes more feasible to do the more costly water tests. Sometimes you just can't get to an area, so you can't get there to do the tests. You can't get there to observe the living things in that area. And so scientists need a way to still be able to check on the water quality in these areas because they affect other areas. And so they use remote sensing. Remote sensing is when you collect data from a distance. So perhaps you have a lake that's up on the top of a very high mountain, maybe in an area that's very remote, and there are no roads or paths, and it's very difficult to get to that area. And so it's either impossible or it's very infrequent that scientists are able to get there to check on that water source. Using remote sensing, they can get an idea of how the water quality is doing in that particular lake. Or perhaps there is a large glacier that is just too large to see all at once, and it's too hard to measure all at once. And so we can use things like aerial photos or satellite images to be able to gather information about these types of areas like the glacier or the mountaintop lake. Sometimes those aerial photos are taken by plane, sometimes by drone. Satellite images are great because they can see a very large area, and they can also pick up things that pictures cannot. You can't always tell from a picture the temperature of the water. If there's ice, then you have a pretty good idea. If it's frozen over. However, if it's not frozen over, there's really no way to know what the temperature of that water is. But by satellite, there are sometimes some ways that you can detect water temperature or things of that sort. So, ladies and gentlemen, I hope that you've had a chance to fill in your information and that you are prepared for your water quality quiz and also getting ready for your upcoming Earth's water test. Have a great day, guys.